This first structure, you should be able to count 1, 2, 3, 4. So that's 4 carbons. 1, 2, 3, 4. There are double bonds here and here. 1, 2 double bonds. And then there are hydrogens. So you fill in until each carbon has 4 bonds. These are planar structures, trigonal planar geometry. So there are no tetrahedra here because the carbons have double bonds. So that's the first molecule. Its name is butadiene. Butane has 4 carbons. Diene means 2 of these double bonds, 2 enes. Second molecule, here's the hexagon, 6 carbons. I'll draw at a slightly different angle. Easier for me to draw the hexagon this way, but you can rotate it if you like. There are 3 double bonds within this structure. Doesn't really matter where you put them. They move, they resonate. Alright, OH on one side. And then there's this Me. What's Me? Methyl. That's what Me is. So that's a tetrahedral carbon. There's a decent representation of a tetrahedron. Fill in these carbons here with hydrogens. There we go. Okay, C. Count the carbons. 1, 2, 3, 4, 5. I see 5 carbons. Try to draw them in the right bonding pattern. So I'm basically just copying the shape I see there. This 5th carbon has double bond OH, clearly shown in the structure here. The 4th carbon has an NH2, which is supposed to be wedged up, which means there must be a hydrogen in the back. All right, here, 1 and 3 must be methyl groups. So there's the 1st and the 3rd carbon with attached hydrogens. Tetrahedral geometry. And this carbon here must have a hydrogen. There we go. So that's the structure I get from this shorthand.